Welcome everybody, and this is the valence swabian. Particles of charge plus 65 plus 48 and minus 95 microcoulomb are placed in a line. The center one is 0.35 meters from each of the others. Calculate the net force on each charge due to the other two. So we're basically using Coulomb's equations, and this is gonna be a repetitive task. We got to do it 3 times for each particle. So here we go. So we have particle A, B, and C. We're gonna start at particle A, and the force due to the particle B is gonna be pushing it away. So particle B doesn't like it, so get off. Instead, particle C love it because they're opposite signs. Particle C is gonna say, come here, come to me. So we're gonna call this force FCA, or FAC is the same, and this is gonna be FBA. So the net force in particle A is gonna be equals. So first of all, we're gonna clarify that this direction is positive while this is gonna be negative. Force CA is gonna be positive, and since the other has opposite direction, it's gonna be negative, minus FBA. Now we're gonna calculate their magnitude. Coulomb's force is equal to K, which is the Coulomb's constant, and has a value of 8.9 times 10 to the 9 times the product of the two charges, 65 microcoulomb, which is 10 to the minus 6. So remember guys that micro means 10 to the minus 6. 95 microcoulomb over the distance square, which is 0.35 plus 0.35. That's gonna be 0.7 meters square. That's equals to 112.15 newtons. Now we need to calculate the force BA, and it has the same constant value, 8.9 times 10 to the 9. The product between the charges is gonna be 65 microcoulomb and 48 microcoulomb over the distance, which is 0.35 square. That's 226.67 newtons. Now we can continue using this formula. Net force in the point A is gonna be equals to 112 times 15 minus 226.67. That's minus 114.52 newtons. So that minus is just telling you that the force goes this way. Now what's going on in the particle B is the same process. You're gonna have this opposite sign charge, so it's gonna be attracting each other. So it's gonna say like, come over me, while the other particle doesn't like each other, like, yes, go over there, I don't like you. So according to that analysis, we're gonna say that the net force at B is gonna be equals to the force A over B plus the force on C over B. So we already know this force magnitude, which is this one. It's just this one, it's the same. We need to find this force. Fc over B is going to be equals to Coulomb's constant. Product between the charges, 48 microcoulombs, 95 microcoulomb over the distance square. And that's equals to 331.29 newtons. So the net force is going to be 226.67 newtons plus 331.29 newtons, which is equals to 557.9 newtons. Now let's go to the last part. So this is negative sign and they're both positive. So this particle is gonna be attracting the other two. So we can say that this is the force B over C, and this is the force A over C. And we already know then we have BC which is the same CB, and we have AC or CA is the same value. So the net force in C is gonna be equals to FAC plus FBC 112.15 newtons plus 331.29 newtons equals to 443.29. So since this is positive, this is the direction, and this is positive as well, so they go this way. And since this is negative, they go to the opposite direction. Have fun, guys. Boom chicka boom boom chicka boom boom.